Okay, so this problem is trying to simulate the Challenger spacecraft disaster, where basically what we have is these O-ring joints between the booster rockets that each had an individual probability of failure um, of that would function correctly with this value, and we want to see like if we have 6 of these that have to function together, what is our actual overall rate of failure that we would predict? And so to start with, we have our failure probability of 0.03, which is related to this value here of the 97.7% chance of not failing. So we've rounded it to 3%. What we want to do is in our values here, we want to figure out what is the probability of the O-ring, first one, second one, third one, all of those failing. So we're going to, again, use a random value. So we type equals if, and we're just going to directly put in there. If that random value is less than this number, and we always want it to be that number, we are going to say that that is a fail. Otherwise, it's okay. And we hit enter. And then we autofill. So we want to see if we're getting some failure. There's some failures, and they're automatically have the conditional formatting on. We want the same idea here. We just are going to now drag that across to all of our ones, and then we can actually double click and apply that down. And now what we have is all of these O-rings and looking at that probability to see what happens if they fail. If we hit the change this to another number, we should see that things update. And so what we want to know is basically if any of these have failed, we want to see what happens. That if any of them fail, then that is a crash. And so we're going to use our COUNTIF function. So we want to know if, equals if. We want to count if. So count if this sum here. So count if this in that range is okay. So if that sum is 6, then it's not a crash. So we didn't have any failures, comma, this one would be a yes. So we're going to apply that down. So basically what we're saying, right, is we count all these. If it's 6, they're all okay. If we count 6 okays, then we're good. If we have one that has failed, then it is a problem. And so these yeses tell us how many times we crashed out of 100 trials. So we're going to have 100 trials here. And so our crashes, percent of crashes, is we now want to have a count if these are yes. So equals count if this range is a yes. So that's a percentage. That's not our percentage value. So what we want to do is we basically want to divide by 100. Or if we want to be a little bit more dynamic, we can divide by count if this range is a yes plus count if this range is a no. So those are our total. I'm just getting a more dynamic percentage. All right, let's see. Did I do that wrong? Count if. All right, so I get 11% of the time it crashed. So even with this 3% failure rate, I'm still getting 11% of the times it crashes because they all have to work together. If I change this to a different number, I see I'm at 14%. I'm at a 26%. That we see that this variation around kind of in the mid to low teens for how many times this actually crashes. We can now adjust our failure rate. Let's say that we have a higher failure rate of 0.05, right? What does that do to our percent of crashes? And so you can adjust those values to start to answer the questions that's outlined in your document.